Ah, math. That's what happens when I eat pizza, or at least that's what gets added to me. Ah, Son Goku. Is there anything you can't pick up? Well, you all know what that means. We conjecture
Although
ahead.
this is going to be weird, and it's going to be about a different.
Title of the conference was something like Ground Truth or Turtles All the Way Down. And so it seems as though there's one Ruliad. I don't think it rules them all. And it might
Yeah,
be just
instead
hyper Rulial Turtles all the way down.
yes, it's on the back of an infinite number of hyperrural turtles.
Various people are commenting on the outrage of hacking the universe on a MacBook Air.
Hey guys, what's going on? Memes here. Yes, I've been away, but at least all I know is that it actually released a video from the most recent physics monastery conference, and I think he listed most everything in chemistry there. So now we can actually go through it since it's at least publicly available. That's important. But what are we talking about today? So, as I had promised to do over a longer period of time, we're going to go through the five base Planck constants. And the claim is basically, in order to form the constants in nature, aside from like a dimensionless constant like the fine structure constant, you might need to do something different to do that. Be pretty cool if we could do it. Um, but basically, you have five-dimensional ingredients: time, space, mass, charge, and temperature. And from those ingredients, we can basically reproduce the results from basically modern physics, or at least for the fundamental constants of nature. Now, it might be a very heavily mixed up, like the Boltzmann constant. It's got like temperature, it's got this, that, and every. It's like it's complex, but it's essentially using a set of units, coherent units, or at least that's what Wolfram Alpha says when you go down the old Wolfram hole. So what are we talking about here? Let's go to our friend Wikipedia. Again, links to all the stuff is in the doobly doo below. Um, so yeah, we go through all that. We've been there before. When you go back and you actually go do more than just glance at, you're like, oh, this actually makes a lot of sense. But all right, what are we talking about today? Planck mass. All right, mass m. All right. So the mass Planck m sub p is the square root of h bar, the reduced Planck's constant, times the speed of light over the gravitational constant. And we take the square root of that, and that apparently gives us this here. So it's approximately, in SI units, 2.176434 with error bars of 24. That's times 10 to the negative 8 kilograms. Now, I have long claimed that I want to be the most powerful wizard on the internet. Will that ever come true? I have no idea. But I'm going to pull some wizardry on you all in a little bit here. It's going to be an amazing claim. Is it true? I don't know that it's wrong. If it's right, fantastic. All right. So we go to our friend code data here again. We got basically that number we had there, that 2.176434 times 10 to the negative 8 kilograms. All right, that's cool. Okay, so we go over here, and again, I need to start actually liking bad as fuck. It's like I'm not. I'm just saying I'm not a big fan of. If somebody wants to check it out, they can. Oh my god, I didn't even link the video where he linked that. It's on the same site that I'm broadcasting on. I'm a terrible human being. But anyways, here's the geometric interpretation. So what we got here? All right. So we got 2 pi. Oh, that would be a circle. That's times 5. Within this construction, that happens to be our red end. So basically, we have 5-dimensional ingredients. All right. We got a circle. We multiply it by 5-dimensional ingredients. Cool. Okay. And then over here, we happen to have it like this, but it breaks out the cosine there. So we got basically cosine squared times 7/5. And that's times e, the base of natural logarithms. And we raise it to the x. And the argument is x is the magnitude of the number we shall receive in order to determine what the Planck mass is. We set that equal to 8, which is the number of derangements, the number of different permutations you can do within this action. Now, people have been asking, it's like, okay, because normally it's 10 to the negative 8. We're taking that 8 and we're throwing in here. And again, I may still have my own skepticism, but all I know is this thing seems to be a lot smarter than I am. So basically, the claim is you can actually almost kind of really see it right here. This is probably a good example. But basically, every time you got to have at least a circle. You're going to have stuff that's doing the thing. What is it? It's a circle. It's going to get the form. Depending on the dimensionality, it may appear differently to us as three-dimensional or 3 plus one-dimensional observers, at least to the best of our knowledge. But basically, if we're basing this off the h of 8, a hyperbolic figure 8 knot. Okay, so you got a circle. It's basically a Geeski manifold. That's half a hyperbolic figure 8 knot. The h of 8 is a double cover construction. So that would be at least 2 circles. So it's a double cover of 5 ingredients. That's 10. We also just happen to be using E, which is the base of natural logarithms. That's the claim. That's what Dad told me. I'm sitting there, I'm like, I can't possibly be right, because that sounds like something I would come up with. Because it's like, well, how would we get there? How would something like this even work? It's like, it, it might, I'll go over some of the physics monastery thing that's there. That explains it a lot better than I am right now. But not to bloviate the point, even though I'm great at that. So our result is 10 pi. Who doesn't like some pi? But hey, third, fourth, a second. Thank you for joining, my friend. Good to see you. But all right, where are we? Yes. So we got 10 pi, 5 circles, times E, Euler matcher. No, excuse me. Euler's number. Euler macaroni. Oh, I want to say macaroni. Both very tasty, I hear. But base of natural logarithm, and we're solving for this. This is our x. This is that magnitude of rotation. So we got our cosine, so that we got some geometries going on here. Square times 7, which are break and scale symmetry. So when you have that circle, and you have those 6 circles in there, and then that last one in the center, so break and scale symmetry. Divided by those 5-dimensional ingredients, that red end, set equal to the magnitude of 8, because, well, it happens to work. We'll delve into it a little bit more later. But, okay. So we have all this beautiful thing. Look at all those cosines, those things. Okay, we get the solution. Okay, and again, the claim is this is the magnitude of the rotation. That's the x we're solving for right here, which should be, according to this model, equivalent to a closed form for the Planck mass. The magnitude is 8 because of those other things we were getting into. And again, we'll explore that deeper later. But okay. So magnitude of 8. So according to CoData, we assume that's right. Again, we're making assumptions here. We're going to need experimentation. We're going to need some observational results. I hear apparently the Large Hadron Collider and LIGO are back online. I don't know. We'll see what happens. So the number we're looking for here is 2.176. Okay. We got 2.176. 434. Oh, wrong thing. 426. Ah, we're off. Yes, we are. And we have error bars at 24. So those last 2 digits, that can go up to a 5 or down to a 1. So, oh, seems to be within the error bars, my friends. Now, again, I don't know. Oh, you guys got to see this. Hold on, let me refresh the page. When Jen stressed to me the importance of logs, I did not fully appreciate it other than the Ren and Stimpy meme. I get a much better appreciation for logs. This is that same thing. X is equal to the log of 4, because occasionally we may quadrant a circle or something like that, maybe a sphere, depending on the dimensionality. divided by 5 pi plus 2 log the secant. Oh, I believe that's an inversion of some of our other geometry we had there. Divide by 7. That's the blue B in the model, the minimal arena or the HF8 model. Divide by our 5-dimensional ingredients. Break and scale symmetry, 5-dimensional ingredients, bada boom, bada bing. And it gives us our answer right there. God, so many logs. But, all right, my friends, appears to be a geometric derivation of the Planck mass. Now, again, is it right? I don't know. It's convinced me enough to go spend about a year of my life at a monastery. I'm just saying, I happen to be in a very particular position, and I find this stuff fascinating, and I think it's important. If I can do something that I love, and it might actually be beneficial, and even if it's not, hey, maybe we can learn something else, or at least find a whole bunch of smart folks that get a lot of good ideas that may be watching now or temporarily in the future to kind of poke along and see what we can do on this grand quest of life. But I see you there, White Chap. Hey, thank you for joining, my friend, as well as Jax. But yeah, we were just going on. I promised to do these other things. I wanted to use a little picture of Goku wearing like the 40 tons of weights and stuff like that. Um, yeah, I believe tomorrow we should have our friend Jaren. And I got a lot of other stuff I can now officially go through. But hey, thank you for joining as well, Eli. I see you there. But hey, take care of yourselves, everyone. It's a wacky and wild world out there. But I think there's some good stuff on the horizon. Or at least some dang good video games, I claim.